So for the next problem, applying the final value theorem, which was for the same, assuming the same transfer function, h of s. Basically, remember what we talked about. Before you can apply the final value theorem, you want to check that the poles are not located on the what plane, left or right? Anybody recall? We want to check that the poles are located on what plane before we can solve for the on the left hand plane, right? On the left. Okay, that's good. So basically we solve for that, I guess, consciously or unconsciously. And basically the poles are fixated on the denominator. We know that one is -3, and then one has a complex conjugate pair, right? So we all have negative real parts. We don't have any positive real part. If we had a positive real part, then of course we expect it to be unstable, right? Because one of the poles would be on that side. So we're going to have some kind of element of instability in the system. And then we could not have been able to apply the final value theorem. But since they're all located on the left half of the S-plane, so we can proceed, right? Again, remember, final value theorem, you're going to write h of t as t tends to infinity, or as is written here. I think this is a typo. This should be s tends to 0. This one here, right? So basically, we're going to have h of t as t tends to infinity, okay? And then the limit of that in Laplace would now be the limit of s times the Laplace of that function, h of t, as s tends to 0. So this is 0. And then that's why we get here. So here you can see they multiply the s again by this. You get this. But this time around, we have to deal with a different animal. Animal is s tends to 0. Here we're not focused on dividing by s cubed. And why is that? If we divide by s cubed and we plug in 0 there, we're going to have 20 over 0. And what is that? What does 20 over 0 give us? It's going to end up giving us what? It's going to give us undefined. Exactly. It's going to give us something that is infinity, because remember we said, undefined infinity are things that we don't want to have in when you're doing limit theory, right? If you're doing limit theory and you have something that says a big number divided by 0, you're going to get mathematical error on your computer, right? So in this way, we have to approach the problem differently. We have to, as long as you can plug in 0 in here on the numerator and you get 0 is fine. But then we want to make sure that in the denominator, we also don't get 0, because 0 over 0 is what? Right? 0 over 0 gives us something that is what? That's a math error. It's like, okay, my gosh, what is this? So when you're solving these problems, you want to be cognizant of the fact that you don't want to get any undefined or infinity expression, or so we have a calculator in the exam, so you can always check that nothing you get should give you undefined. Okay, so looking at this, I indeed have seen that we have a term that will make everything not undefined. So therefore, I can just plug in 0 here. I'm going to have 0 over 75, right? And that's 0. So 0 over a number is 0. So that's good. So we're good with that. So there are different tactics and different approaches you can do. Just avoid getting undefined or infinity or 0 over 0 or something that doesn't exist, or will give you a math error. Okay. I am pretty sure that there may be other approaches for solving for the initial value theorem, where we wouldn't have had to actually look for the highest order term and divide through. But it's possible that they can make a question like that, right? But just remember that the whole point was that we did not want to get something that would be 20, that would give us something that would not make sense, right? Because 20 over infinity is 0. And we kind of hope that we're not going to get 0 here, and we got 1. And 0 over 1 is 0. In this particular example, everything ended up being 0 and 0. But please don't feel like in the exam that everything will be 0 and 0. It could be a different number. All right, so let's kind of test our skills, right? Let's look at an example problem. I can ensure that the answer should not be 0 in this one. So that's my hint for you.